Dr. Shiju, please, next. Interesting, it's not just startups, it's not just the big companies that are doing IoT platforms. So Dr. Shiju from Amrita University, he has devised the entire IoT sensor to the cloud platform. It's an amazing story. And with a complete IoT platform as well, including the edge nodes, the gateway, and so forth. So let's hear him out.
Good afternoon all. I'm Shaiju representing Amrita University. Amrita University is actually an initiative of Mata Amrita by Mat, which is derived by Amma. Even though this project is, even though the work that we have done so far is being funded by Government of India in 2013, we got a 3.25 crore funding from DAITY. Even though we did this, a massive amount of this work has actually gone into the 148 villages that the MUD has adopted to make people's life easy. And this is an ongoing process. If you want to know more details about it, if you go to amrita.edu and search for Live-in Labs, you can get more details about the same. As most of the people who's already talked before me has talked about, Amrita Internet of Things ecosystem consists of an IoT middleware, a dedicated gateway, which we call it as it's an intelligent heterogeneous protocol in the sense that it can actually support several protocols at one go. That means it can support 6LoWPAN, UPnP, Wi-Fi, all that protocol stack in one single gateway at one go. How is that possible? We actually come out with a patent pending layer called protocol characterization layer. Now, as most of the people have been talking about, standardization is something which is absolutely not going to happen in the space of IoT unless somebody can come and say that no more protocol development, no more development of any more messaging queues. If somebody can come out with that, then someone can go to standardization. Otherwise, it's up to us to develop some kind of a mechanism which will automatically or will have sufficient intelligence to adjust and work with new protocols. That's what protocol characterization does. It uses a genetic algorithm based and a profiling technique which actually uses its intelligence to profile the existing protocols, and it uses that to work with new protocols. We try to put a new protocol onto it and a new device. Having a new protocol, it actually uses that technique to build the new seeds that is required to build a profile to talk to that device. So protocol characterization layer not only does that, but also it actually makes sure that you have a stable connectivity, resilience. If something goes wrong, it actually tries to rebuild the whole thing. Connectivity lost, it actually runs everything. If that means connectivity to the cloud is lost, but your sensors are still streaming data, it actually makes sure that your data is actually being populated and then pushed back to the cloud as per how it is being, so that you don't have any data loss. The entire stack is so thin that it can even run out of Orange Pi. It can run even out of Orange Pi. It can run from Orange. We have tested it across a wide range of evaluation boards, and it's pretty stable. The talk that I gave yesterday, which we have a live implementation of Karshaga Amrita, which is an automated irrigation control system. Protocol characterization layer based gateway has been running stable for a year without even needing to shut it down. So we have proven the capability of that. And the capability of the gateway is that it can run IoT applets. So you can download your applets directly onto that and run your applications directly onto it. That means one of the major issues and worries that people always have is the latency, and latency is totally cut off with this. So you don't have to have any kind of connectivity to the cloud for critical systems to work. Everything works locally, and then still you can get your data onto the cloud, which is purely for processing. Decision making doesn't have any dependency. We have a set of low-cost IoT enablers because most of the devices are very costly. You take a gateway or modes, or you take up any devices, it's extremely costly. We have come up with different versions of very low-cost devices. Then we have a big data framework and also a dynamic dashboard. Big data framework is kind of a framework we can sit on top of existing Spark and also Hadoop clusters, and it uses a GUI-based interface for you to build any kind of pipeline to process static data or streaming data, and also it have a horde of machine learning algorithms built into it, no dependency whatsoever on any libraries, everything built by us from scratch.
Professor, why don't you go to the use case? That would be a very interesting thought process.
So this is the kind of security architecture which I think most of you are following it. It makes our life much easier. We divide the whole IoT architecture into external, internal, and also at the edge nodes. The security is also being designed based on that concept. And then this is the overall stack that we have defined based on, sorry, I'm actually rushing through because of less time. So the stack will actually give at each gateway layer, at the middleware layer, at the UI layer, and also at the base intelligence P-cards layer, how you actually build up your entire framework. The advantage is that it's so modular that you can actually plug and play. You can actually throw in what components you want. So if you don't want MQTT, just throw it out, put ZMQ in, and if you don't want that, you can put RabbitMQ in. So everything works, in sync. So it's very well modularized, even at each individual levels. This is the IoT gateway I talked about. As of now, it's actually support all this protocol at simultaneously. It can actually run all together. So the protocol characterization layer handles it. And this is the explanation I told about protocol characterization layer before. These are the different security aspects that we already covered. It's already been taken care. Some of the objects, some of this has already been discussed in the security layer the discussion that we had, and we addresses most of the case. One of the major things that was actually discussed was actually about port scanning, and we have a mechanism for stopping the port scanning, and that is called port guard, which can go into the gateway. And also we have a behavioral based system which actually profiles the entire IoT network, which actually stores a profile of how your network behaves and stores in the gateway, and then it uses that to detect an anomaly. That means you're taking off all, your edge nodes are not overloaded with any kind of thing, so you don't even have to have hardware security done onto that. This is the various layers of security that's been incorporated. One single place, you actually can monitor the entire network that you have. That means all the gateways, all the devices, how your gateway performs, what's the memory, what's the CPU, what's the load, how many packets you receive. Everything you can actually monitor from just one single place in the entire network.
So it's a complete gateway, complete kind of IoT platform, customized platform, Professor has defined.
Again, devices, when our concept is like you don't need to make any changes to your devices.
Correct.
You throw in your devices, you ask your middleware to discover the devices. It will even discover your neighbor's devices. But the thing is, like, you should not be able to see the data. That's why it actually has a capability that middleware does not expose that. I've got the capability. As a hacker, I can do it. So middleware does not expose that unless it will put the credentials of the devices. It will actually make it visible for you to interact with it. So it makes it life much easier for a developer. So these are the various device discoveries. These are the various papers that is available. This is actually during the initial. This is going to be very useful because we have done even some of the attacks on existing cloud platforms like Carriot, where we were able to use device cloning, and we were able to enter as a device, as a duplicate device. This is a quick rundown of the Amrita Big Data framework. This is the kind of pipeline that's available. Hordes of algorithms, all running on streaming or on Spark or in Hadoop. It's available. Only thing you have to do probably is just select what mode you want to run in, and it actually automatically translates the entire thing to run on Spark or in Hadoop. So this does not mean it does not confine itself to Spark. It actually confines to streaming data, to any kind of data.
So Professor, I would please request you to stop out here.
Okay.
This section is the presentation and so forth will be up on the website. I have just one quick question before we end. Unfortunately, that other session is starting up in the other place, other room. So I have a quick, please have your seat.